Think about like your standard washing machine. I mean, it's an absolute miracle of traditional automation.
No, for sure.
You
Yeah.
put the clothes in, you press heavy duty, and it runs this very specific, rigid cycle. It fills with water, it spins, it drains.
Right. Just blindly follows the steps.
Exactly.
Huh?
But if you accidentally drop your smartphone in there, the machine doesn't care. It doesn't look inside, panic, and pull the phone out. It just washes the phone.
Which is a very expensive mistake to make.
Yeah, totally, because it's a machine following a script. But imagine if you had a machine that looked inside the drum, recognized the phone, gently pulled it out, put it on the counter, and then like actively decided the water temperature based on the specific fabrics it was seeing.
See, at that point, you aren't really operating a piece of hardware anymore. You are interacting with an entity that has autonomy.
And that leap is exactly what we are unpacking today. Welcome to the deep dive. We are going through some incredibly fascinating notes, sort of May 2026 Agentic AI podcast guide.
It's a really comprehensive look at where things are heading.
It really is. And our mission for you today is to figure out how to navigate this monumental shift. We're moving from traditional AI, which, just answers questions, to agentic AI.
Right, AI that can autonomously achieve these complex multi-step goals.
Okay, let's unpack this. Because
Yeah.
if traditional AI is like walking up to someone, asking a trivia question, and getting an answer.
Then agentic AI is, well, it's like hiring a proactive assistant.
Yeah, like you hand them a vague goal, and they just go off, do the research, draft the document, check their own work, and literally just hand you a finished product.
And what's fascinating here is that we are not simply talking about a software update or like a faster processor.
Yeah, way bigger than that.
It is a fundamental paradigm shift in human-computer interaction. Because, I mean, for decades, computing has been this single-turn interaction. You click a button, the computer does one thing.
You ask a chatbot a question, it gives you one answer.
Exactly. But agentic AI introduces sustained, goal-directed behavior. We are officially moving from AI that just thinks to AI that acts.
But to really grasp how these new agents actually do things, I feel like it helps to look at the brick walls the old systems kept hitting, right?
Oh, absolutely. The historical context is crucial here.
Because the sources trace this all the way back to 1966 at MIT with a program called ELIZA. Now, I've always heard ELIZA called the first chatbot, but was it actually intelligent?
It had zero actual intelligence, which
Yeah.
honestly is what makes it such a great starting point.
Really, zero.
Yeah, none at all. ELIZA relied entirely on simple pattern matching. It was sort of acting as this mock psychotherapist.
Yeah.
So if a human typed a sentence that happened to include the word mother, ELIZA was programmed to just spot that specific string of characters and output a pre-written response.
Like, tell me more about your family or something.
Exactly. It was a clever parlor trick, but strictly rule-based. It had no understanding of what a mother actually was.
So it was literally just a giant list of, if the user says X, print Y.
That's all it was.
And the notes show that this rule-based approach stuck around for decades. Like, in 1995, we got Alice.
Right, using a more complex markup language called AML.
Yeah, but to do essentially the exact same thing, right? It was just an infinitely larger list of rules. So when did we actually break away from that?
The real shift came with the machine learning era. Instead of human engineers trying to, manually write a rule for every possible conversation,
Which is impossible.
totally impossible. Instead, they built systems that could be trained to recognize patterns in massive mountains of data. And this is what gave us the virtual assistants we all got used to in the 2010s.
Right. Siri in 2011, Alexa in 2014. I mean, I use them all the time, but they still feel pretty limited. How were they actually processing my voice commands back then?
They relied heavily on two main concepts, intent classification and slot filling.
Slot filling. What's that?
Well, first, when you spoke to the assistant, it tried to classify your intent. It would decide, oh, the user wants to book a flight.
Okay, that's the intent.
Right. Once it knew that, it moved to slot filling, looking
Yeah.
for the missing variables. Like, it needed a destination slot and a date slot.
So it would ask you for the city and the day.
Exactly. It just filled the slots.
Which is helpful, but it's still just a very fancy single-turn system. Like, I ask for a flight, it books a flight. It couldn't sustain a complex project over an hour.
No, not at all.
The real earthquake, according to the source notes, happened in 2017 with a research paper from Google.
Yes. Attention is all you need. It is arguably the most important computer science paper of the modern era.
Wow, really? The most important.
I'd say so. It introduced the transformer architecture. See, before transformers, AI read text linearly, word by word.
Like how we read a book.
Yeah, but for a computer, that made it lose track of the context in really long sentences. The transformer allowed models to process text in parallel.
Okay, processing everything at once.
Right, and crucially, to pay attention, hence the title, to the relationships between all the different words in a sentence simultaneously.
And this breakthrough is the foundation of modern large language models.
Exactly. The LLMs, your GPTs, your Claudes.
But even then, like those early LLMs were just text generators. They were these brilliant encyclopedias, but they couldn't actually do anything in the real world.
They were isolated brains.
Yeah. So that brings us to 2023, with open source projects like AutoGPT. This is where researchers finally started connecting these LLMs to external tools.
And that is the birth of true agentic behavior.
Okay, so if traditional automation is a train stuck on a track, and traditional AI is a super smart encyclopedia, then agentic AI is like an off-road vehicle with a GPS.
I love that.
Like it can reroute itself when it hits a roadblock.
That analogy perfectly captures the core mechanic.
Yeah.
The defining characteristic of an agentic system is self-correction.
Self-correction, okay.
But think back to your washing machine example. If traditional automation hits an unexpected error, say a sensor breaks, the whole machine halts.
Right, it just flashes an error code and beeps at you.
It crashes. But an agentic system can recognize that a failure occurred. It can read the error message, analyze why the previous attempt failed, and actively rewrite its own approach to bypass the obstacle.
It just keeps iterating until it succeeds.
Precisely.
Okay, so we know what agentic AI is,
Yeah.
and we know how we got here. Now we really have to ask, how does it actually do things?
Let's break it down into the brain and the hands.
Yeah, the notes separate the brain of the operation from the hands. Let's start with the brain, which is obviously the large language model. I hear the term tokens thrown around constantly.
It's the fundamental unit of LLMs.
What does that actually mean for the AI? Does it read letters like we do?
It doesn't read letters, and it doesn't quite read whole words either. It processes text in chunks called tokens.
Like word fragments?
Yeah, you can think of a token as a word fragment. For instance, a long word like understanding might be mathematically split by the AI into the tokens under and standing.
Oh.
But a short word like apple might just be a single token. Every single prompt you type and every single answer the model generates is measured in these tokens.
And that naturally leads into the context window. I see that term everywhere too. Is that basically the model's active workspace? Like its short-term memory limit?
That is exactly what it is. The context window is the absolute maximum number of tokens the model can hold in its active memory at one time.
And the early ones were pretty small, right?
Tiny. They would forget what you asked them like 3 paragraphs ago. But modern models, they have context windows of 200,000 tokens or more.
Okay, put that into perspective for us. How much actual reading material is 200,000 tokens?
It is roughly equivalent to a 500-page book.
You're kidding.
No, it's massive. An agent can hold an entire corporate code base or a huge stack of legal contracts in its head simultaneously while it analyzes them.
That is a staggering workspace. I've also noticed this setting called temperature when looking at agent configurations.
Ah, temperature. That's a fun one.
What does a thermometer have to do with text generation?
So temperature is the mechanism that controls randomness in the model's output.
Randomness. How so?
Because an LLM is essentially just calculating the mathematical probability of what the next word should be, right?
Yeah.
So a low temperature, like setting it to 0, forces the model to always pick the absolute most probable word.
Oh, I see. It makes the output deterministic.
Highly predictable and deterministic, yes.
So if I'm having the agent write a Python script or pull financial data from a spreadsheet, I want the temperature at 0.
Right, so it doesn't get, creative with the numbers.
Yeah, nobody wants a creative accountant AI.
Exactly. But if you are using an agent to brainstorm marketing copy or write a poem, you turn the temperature out.
To inject that randomness.
Yes. It allows the model to occasionally pick less probable words, which we as humans perceive as creativity.
Okay, here's where it gets really interesting for me. We have this brain. It can hold hundreds of thousands of tokens. We can dial its creativity up or down, and it's brilliant at predicting text. But if an LLM is essentially just this advanced autocomplete, how on earth does it actually use a tool? Like, how does it send an email to my boss? It doesn't have physical hands.
It interacts with the world through a mechanism called function calling, and that relies heavily on prompt engineering.
Function calling. Okay, walk me through that.
To give an agent these hands, developers start with a system prompt. This is essentially the agent's hidden job description.
Like the rules it has to follow before you even start typing.
Exactly. It tells the model, you are a helpful assistant and you have access to a specific email tool. The developer might also provide few-shot examples in that prompt.
Few shot, meaning they show the AI a few examples of what a successful tool interaction looks like.
Yes, showing it the exact pattern. So when you type to the agent, send an email to my boss asking for a meeting, the LLM analyzes your request.
Right.
It cross-references it with its system prompt and realizes, uh-oh, I cannot fulfill this request just by talking. I need to trigger the email tool.
But wait, software tools, like an email server API, they don't speak conversational English. They are super rigid. How does the AI cross that bridge from text to actual software commands?
By switching languages, basically, the agent actually pauses its natural text generation.
Really, just stops.
It stops, and instead of outputting English, it generates a highly structured block of code, typically using a format called JSON schema.
JSON, I've heard of that.
Yeah, JSON is just a way of organizing data into strict key-value pairs. So the agent outputs code that essentially says, action, send email, target, boss, subject, meeting.
Oh, well. So it writes a little package of code in a format the rigid software can actually digest.
That is the core mechanism right there. The underlying system takes that JSON package, executes the actual code to trigger the email server, and then the server sends back a status message.
Something like, email sent 200 OK.
Exactly. The agent reads that success message, switches back to conversational English, and replies to you saying, I've sent the email to your boss.
That is wild. And the source notes list tons of these tools. Information retrieval tools for web searching, action tools for modifying files, computation tools for running math.
Communication tools for Slack, yeah.
But if every single software application in the world requires a slightly different format for that JSON package, I mean, that sounds like an absolute integration nightmare for developers.
It was a massive bottleneck. Integrating an AI with an external database required writing really fragile custom plumbing for every single tool.
Which breaks every time there's an update, I bet.
Always. But the source material highlights a massive game changer here. The Model Context Protocol, or MCP, introduced by Anthropic.
Yeah, the notes refer to MCP as the USB for AI agents, which is a great way to put it.
If we connect this to the bigger picture, think about the early days of personal computers. Before the universal serial bus USB existed, every device needed a proprietary cable.
Oh man, don't remind me. Your printer had that massive parallel port with the screws.
Your mouse had a serial port. It was total chaos. But USB created a universal standard. That is what MCP does for AI.
It's an open standard.
An open universal protocol. Any MCP-compatible tool can instantly plug into any MCP-compatible agent, completely eliminating the need for all that custom integration code.
Okay, so thanks to MCP and JSON, our brilliant brain now has incredibly capable hands. It can pull levers across the internet.
It can.
But honestly, a super fast brain with robotic hands is kind of a massive liability if it doesn't look before it leaps.
Very true.
Like if I just tell an agent to handle my inbox, what stops it from immediately replying to a sensitive email with something completely inappropriate?
And that is exactly the crux of the problem with early impulsive agents. Having capability is dangerous without planning.
Planning, okay.
If you tell a basic reactive agent to write a 20-page industry analysis, it will likely just start typing the introduction immediately.
Without even checking if it has the info.
Right. And by page 4, it will realize it doesn't actually have the necessary data, and the whole output just falls apart. So a sophisticated agentic system utilizes task decomposition.
Task decomposition, meaning it breaks the massive goal down into an actionable checklist before it ever touches a tool.
Exactly. It maps out the subtasks, like step 1, outline the structure, step 2, search the web for market data, step 3, write the first draft, step 4, review against the prompt.
That makes so much more sense.
And developers use specific prompting techniques to force the model into this planning mindset. One is called chain of thought, or COTI.
Chain of thought, meaning we literally command the AI to show its work, like a middle school math teacher would.
That's a great analogy. By instructing the model to explicitly write out its reasoning step by step before it arrives at a conclusion, it dramatically reduces logical errors. Taking that a step further, we have the REACT framework, which stands for reasoning plus acting.
How does REACT differ from just thinking out loud with chain of thought?
It creates this continuous loop of observation. The agent reasons about the goal, takes a single action using a tool, observes the specific result of that action, and then pauses.
It stops to assess.
Right. It pauses to reason about its next step based on that new reality.
Wow.
And for highly complex scenarios, the notes mention the tree of thought technique.
Tree of thought, like it branches out.
Imagine a grandmaster playing chess. They don't just think one move ahead.
Right, they see the whole board.
They visualize 5 different possible moves, evaluate what the board state would look like for each one, and then choose the single most promising path.
That's crazy.
Tree of Thought allows the agent to explore multiple different problem-solving strategies simultaneously, evaluate them, and prune the dead ends before committing to an action.
That is incredible. But wait, if an agent is exploring multiple paths, running searches, and drafting 20-page reports over the course of, say, 3 hours, doesn't it eventually run out of space?
In the context window.
Yeah. Even 200,000 tokens has a limit. If the project takes days, it's going to get amnesia.
It absolutely will get amnesia, which is why we had to invent long-term memory for AI.
Okay, because the context window is strictly short-term memory.
Exactly. It's the mental scratch pad for the current session. When the task outgrows the scratch pad, we rely on a technique called RAG, retrieval augmented generation.
I see RAG mentioned constantly in AI circles. If the short-term memory is the scratch pad, what is RAG actually doing behind the scenes?
RAG works by taking massive amounts of data, say your entire corporate archive of PDFs and chat logs, and running them through an algorithm that converts the text into mathematical vectors.
Wait, vectors?
Yeah, they're called embeddings.
So it turns English sentences into coordinates on a giant graph.
Yes, and these coordinates map the actual semantic meaning of the text. Words with similar meanings cluster together on this multi-dimensional graph.
Oh, that's wild.
These vectors are stored in a special vector database. So a month later, when your agent is trying to answer a complex question, it doesn't need the entire corporate archive in its context window.
Right, it couldn't fit it anyway.
Exactly. It just converts its current question into a new vector, drops it onto the graph, and the database instantly retrieves the specific paragraphs that are mathematically closest in meaning.
That makes perfect sense. It's how you give an agent access to a million-page library without overwhelming its short-term memory. It just pulls the exact sentence it needs right when it needs it.
And without RAG and robust memory architectures, the agent would hallucinate details it forgot. The source material outlines several memory types, actually.
Like what?
Well, there's a conversation buffer to remember recent dialogue, a summary memory to condense past interactions, an entity memory that tracks facts about specific people.
Wow, so it remembers who I am.
Yes, and an episodic memory for recalling past events. Furthermore, this memory is vital for error recovery.
How so?
If an agent tries to use a software tool and it fails, it needs that long-term context intact to diagnose why it failed. Otherwise, it just infinitely repeats the same broken JSON code.
It would just be stuck in a loop. Okay, so we have a highly capable agent. It plans its work. It remembers the past. It uses tools to affect the real world. What could be more powerful than that?
A team of them.
Exactly. According to the notes, it's when we stop talking about one agent and start talking about a whole team. Let's dive into the AI workforce, multi-agent systems and orchestration.
Because, just like human organizations, multi-agent systems divide complex work among narrow specialists.
Makes sense.
An agent that tries to be a researcher, a coder, and an editor all at once usually fails. It's too much context switching.
So we structure these synthetic teams.
Right. There are a few ways to do it. There is the hierarchical architecture, where a high-level manager agent receives the human prompt, breaks down the project, and delegates subtasks to specialized worker agents.
That sounds like my office.
Very similar. There's also the peer-to-peer collaborative approach. But for things like content creation, the pipeline architecture is incredibly effective.
The pipeline is basically an assembly line, right? You have a researcher agent that scours the web and gathers the raw data.
Yep.
It hands that data off to a writer agent who drafts the copy. Then the writer hands it to an editor agent who polishes the grammar and checks the facts.
It's a very clean handoff.
But looking at the source material, it also mentions a debate or adversarial architecture. Now hold on, a debate system.
Yes, a debate system.
I've been in corporate meetings where two humans debate a spreadsheet for an hour and get absolutely nowhere. If I set two AIs to debate each other over an analysis, aren't they just going to infinitely argue in circles and run up an astronomical cloud computing bill?
This raises a very important, very practical question. The cost and complexity of multi-agent systems are significant bottlenecks right now.
I mean, every message costs money, right?
Every single message these agents send back and forth consumes tokens, which costs real money. The debate architecture is actually brilliant for finding flaws in logic, like having a generator agent propose code and a critic agent try to break it, but it needs strict boundaries.
Yeah. Otherwise, they just argue forever.
Exactly. And this is precisely why we need the engineering discipline of orchestration.
Orchestration, I like that. The sheet music for the synthetic symphony.
That's beautiful, yeah.
Yeah.
Orchestration dictates the workflow patterns and keeps the agents from running amok. Let's say you have a massive task, analyzing 10,000 PDF financial reports to extract specific ESG metrics.
Okay, massive task.
You wouldn't use a simple linear pipeline for that. It would take way too long. You would use a MapReduce workflow.
MapReduce. Walk me through how that actually looks in a multi-agent scenario.
First, the orchestrator maps the task. It
Okay.
splits those 10,000 PDFs into small batches and spins up hundreds of identical worker agents in parallel,
All at the same time.
simultaneously. Each agent reads a few PDFs, extracts the metrics, and outputs a brief summary. That's the map phase.
Okay.
Then comes the reduce phase. Another agent takes those hundreds of summaries, aggregates them, resolves any conflicting data, and distills them into one single coherent master report.
So a task that would take a human months or a single agent weeks is handled by a swarm of parallel agents in, what, an hour?
Sometimes minutes. And developers are using incredibly powerful frameworks to build these orchestrations.
Like what kind of frameworks?
Well, LangGraph represents workflows visually, connecting agents through nodes and edges. Crew AI focuses heavily on defining specific personas, roles, and backstories for collaborative crews.
Oh, giving them like job titles.
Yeah, exactly. There's also the Claude Agent SDK from Anthropic and Microsoft's AutoGen, which actually excels at managing those conversational debate systems you mentioned earlier.
But going back to my fear of an endless expensive debate loop, or just a worker agent whose search tool keeps crashing.
Yeah.
How do these frameworks actually prevent a total system meltdown?
Through rigorous state management.
State management.
The state is the exact snapshot of everything the system knows, every variable, and every action taken at a given microsecond. Good state management allows a massive workflow to be paused, inspected, and resumed without losing progress. But more importantly, orchestration implements circuit breakers.
Like a circuit breaker in my house.
Yeah.
If there's a surge, it just cuts the power to stop a fire.
Exactly the same concept. If a particular tool's API goes down, or if two agents in a debate system exceed a set number of turns without reaching a consensus, the circuit breaker trips.
It just cuts them off.
It stops the infinite loop. At that point, the system employs human escalation.
It tags in a human.
Right. It pauses the workflow, pings a human manager for help, and provides the complete state context of what went wrong so the human can untangle the logic.
Wow. So what does this all mean for you, the listener? We are undergoing a massive transition in how we work. We are moving from being operators of rigid software tools to managers of synthetic teams.
It's a huge shift in identity.
It really is. Whether you are prepping for a major strategic meeting, analyzing a massive spreadsheet of quarterly data, or building a marketing campaign, Agentic AI changes the fundamental nature of your day-to-day workflow.
You're stepping back from the microtasks.
Exactly.
Okay.
You are no longer executing every single step yourself. You are defining the high-level goals, providing the appropriate tools, and managing the orchestration of these multi-agent systems.
And that leads to one final thought for you to chew on as we wrap up today.
Oh, let's hear it.
We've talked extensively today about how these agentic systems can continuously reflect, self-correct, and even rewrite their own code or adjust their tool usage to overcome unexpected failures.
Right.
At what point does a system with that level of autonomy stop being a predictable software tool and start becoming a synthetic employee with its own unique, evolving workflow habits?
Oh, wow.
Think about it. If an AI develops its own preferred way of working, its own strange quirks in how it solves problems, how will human managers have to adapt their leadership styles to manage non-human logic?
That is wild to think about. I
Yeah.
mean, we started this deep dive by comparing this technology to a washing machine, but you don't really have to adapt your leadership style or check in on the emotional state of your laundry.
Not yet, anyway.
Managing a synthetic employee with its own evolving habits, that is a whole new frontier of management. Thank you so much for joining us on this deep dive into agentic AI. Keep exploring, keep questioning, and we will catch you next time.